I'm Xiulin Ruan. I'm a professor in the School of Mechanical Engineering and the Berkeley Nanotechnology Center at Purdue University. We're trying to find ways, can we come up with materials that can help, the energy sector.
Obviously, people have known for a while that white paint reflects sunlight and can help keep buildings cool. Like what's kind of the difference between what you set out to address and the difference between like what you can buy in, Home Depot or sort of the whitest paint that was available?
That's a great question. Actually, indeed, the commercially available white paints, they can cool surfaces better than the darker color surfaces. However, the paints available, they reflect sunlight to the level of 80 to 90%. Which means that these paints still absorb 10 to 20% of sunlight. Although they emit infrared heat to the deep space, but the absorbed sunlight is too much. So what we really pushed about our paints is to minimize the absorption to the sunlight. So that's why the whitest comes to the picture. We were able to reduce the absorption to less than 2% because our reflectance is a 98.1%. Okay, that's a big deal. That cut down the absorption to the sunlight by a factor of 5 to 10. That's why it took so many years, because we really had to combine all these factors and push them into extremes to achieve this extreme performance. If we miss one of them, performance definitely would not be there. After we kind of published our calcite and the barium sulfate formulations, we got a lot of inquiries, especially people from, for example, aerospace industry, space industry, and even wearables or clothing companies. They ask us two questions. Can you make it thinner? Can you make it lighter? I had to look for the solutions. I mean, we got inspired actually by the different morphology. I mean, the hexagonal boron nitride, it has a platelet geometry. So intuitively, these platelets can block the light more effectively because they have a larger cross-sectional area. So yeah, we experimented this material, and again, there are some challenges because it bounces back better. Also make the paints much more viscous. So initially, we're not able to really brush or spray. It's just like a gel. So it took us some journey to figure out how to use the right solvent, right binder, and make it paintable, sprayable, and brushable. And so it turns out that now with this new formulation, we're able to achieve nearly the same reflectance at only 150 micron thickness. That's a kind of a significant reduction. The weight reduction is even more, because the density is much less than the barium sulfate.
Can we buy these paints in stores? Like, what other kinds of paints are you guys gonna look at like going into? Like, what's on the horizon for you all?
Sure. Yeah. Currently, we're partnering with industry collaborators in the process of commercialization. There are a few issues we're working on. We need to have tests on the durability and make sure it can last as long as the commercially available paints. The second, many applications, we would like to minimize the use of solvents so that is environmentally friendly. Okay, so this is ongoing right now, and hopefully we can push the white paints in a reasonable amount of time. And going next, we try to develop color paints based on our white paint formulation, because color paints is developed by mixing the colorants to the white paints. So our white paint does provide a good platform for that new development. The other development we're thinking is that can we switch between cooling in the summer and heating in the winter? So this will make the paints not only be very attractive to the hottest climates, but for the climate zones with the seasons, it will be able to save the energy better and help with our climate better.
Don't forget to subscribe to our channel and check out other Gizmodo videos here on YouTube.